Hello everybody, welcome back to another video. In today's video I'm going to be showing you how to code a simple neural network. This is probably going to be the first part of 3. So yeah. So the first thing that we want to do is we want to have layers, and each of those layers is going to need a weight and a bias. So I'm not going to explain how neural networks work in this. They're really complicated. I just kind of want to code one. So yeah, so we're going to have weights and then we're going to put 1, and that's because this is layer 1, so these are all the weights for layer 1, and we're just going to initialize some random things, so, and then maybe, I don't know, there we go. And each of these, so 0.1, that's the weight for, a node. It's kind of confusing, but yeah. Then we want to do node bias 1, and these are the biases for each of the nodes. Then we have the same amount of biases as we do weights, because again, each one of these is just a node in the layer. So now that we've done that, we want to do this, like that. We want to have another one, so we'll do node weights. This time it's going to be layer 2. We're going to do 0.6, 0.2, 0.4, then maybe another 0.2. Then we'll just initialize the biases for that layer. There we go. And then maybe we'll have one last layer. So now that we've gotten that done, let me kind of go through and explain it a bit more to you. So each one of these, so this and this, represent a layer in our network, and each of these is a weight that connects to a node, and then each of these is a bias of that node. So kind of confusing, but if you can get your head around it, then you can. But yeah. So now we want to define our network. This is just going to be nice and simple. Now in here we want to initialize things like the learning rate, and for this neural network, all we're going to be aiming to achieve is we give it a random number, and it can output. And it can change its weights and biases so that it can output a number that we want, if that makes sense. So here we're just going to define learning rate. And that's just going to equal 0.0001. Then we're going to want given. It's just going to be our given value that we're giving it. And then output is going to be what we want it to output, basically. Now this is where we're going to need to start to work with layers and stuff. It's not complicated. All we're doing is we're going to take the sum of one layer's predictions and input it is the input for another layer. So we're going to do for I in range 10,000. Then we're going to want to do layer 1. Then we're going to want to do layer 1 pred, which are the predictions of layer 1, which is going to equal a list. Then we want to do for NWLM, and that's basically saying for node weight element, and for NBLM, so node bias element, in the zip, node weights and node bias. We're just going to want to add a 1 there, and we're going to want to add a 1 there. We want to do pred, or prediction, is equal to the given value times by NWLM plus NBLM. Then we just want to do layer 1 pred dot append pred. You can see here that if we call network, and then we print up here, if we print layer 1 pred, we run this, you can see that we get its predictions. It's predicting 8.2, 3.13 and 1.8. Now those will be changed over time, but for now that's just what it's predicting. Then we want to do layer 2, but I'm not going to get into layer 2 this time. We're going to do layer 2 in part 2. So yeah, but if you want to see me continue this and you want to see how this works out, then let me know. Drop a comment, like and subscribe. Thanks for watching.